There we go. Okay, so we predicted the products, and as far as just simply putting the two parts together, front part of this goes with the back part of that, and we get this. Front part of this goes to the back part of that, we get that. Subscripts like this don't travel. The only subscripts that do travel are those that are part of a polyatomic ion, so we move this one over. That's part of the nitrate ion. We have to balance the formulas. Now, the name of the lead compound was lead 2 nitrate, so this we're going to assume is also lead 2, and iodide has a -1 charge, so when we balance this, we'll have PbI2. Potassium has a 1+ charge, and nitrate has a 1- charge, so we need one of each of those. You look on your solubility rules, and you'll see that group 1 salts, and this is a group 1 salt, are always aqueous, and so are nitrate compounds always aqueous, or soluble, and since there's water around, this will be aqueous. Okay, and then you look at this, and you'll see that iodine compounds generally are soluble, but not when they're combined with certain things, and one of those certain things is lead. So this is an exception to being soluble. This is insoluble, and so there's the product you were collecting. Okay? Then you have to balance the equation. We use what to balance an equation? Atom inventory. I'm going to skip that just for time here, okay? I hope everybody knows how to do an atom inventory. If you don't, you really need to come in and get help with that. You need to be good at it. And when we balance the equation, we have a coefficient 2 here and a coefficient 2 here. Okay, and that'll balance the equation. Did everybody get that part right? Anybody have any problems with that? Okay. What? Yeah, we've done it a lot. What? It doesn't matter. These can be switched and these can be switched. As long as you have everything on the left and everything on the right, doesn't matter what order. Okay? All right, so now here's the thing that will be different for everybody. You get to choose which reactant to start with to figure out your limiting reactant. Okay? So you could start with your measured amount, and everybody's measured amount is different. I set it up that way. You can start with your measured amount of lead 2 nitrate, or you could start with your measured amount of potassium iodide. Either one of those is fine for you to start with, okay? Because the results will be you should get the same results either way. And you can always do the math if you want to and see. Okay? Huh? I'm going to do both. It's not very hard to do the second one once I do the first one. Okay? All right, you have to calculate the molar mass of both lead 2 nitrate and potassium iodide. So let's see. Here's lead, nitrogen, oxygen. Lead is 207.2 atomic mass units. And nitrogen is 14.0067. And in the formula there are 2 nitrogens. And then oxygen is 15.9994. And there are 6 oxygens. What? Oh, I've got it. 207.2, 28.0134, 95.9964. All right. Remember, when you're adding, anytime you have empty slots in a column, that means the resulting digits get rounded off. 331.2098. And these last 3 digits then are going to be rounded off. And that's going to give us 331.2 grams of lead 2 nitrate. And you're going to show that that's, since the molar mass is by definition the sum of all the atomic masses of all the atoms in a formula, this is the molar mass, but in this class I want you to also set that equal to 1 mole of lead 2 nitrate, so that you've got an equality statement to work with. Okay? And then from this equality statement, we're ready to build a conversion unit. Conversion units always have equality statements, and in this class they're required. Sometimes they're implied, but in this class they're required. So we want to match the units and species on the bottom of this fraction with what we started with here. So this side of the equality statement goes in the bottom. This side of the equality statement goes on the top. Okay, cancel units and species. And we're ready for the molar ratio. The molar ratio is where you change from one species to another. This is not going to give us a conversion unit because a unit equals 1. A molar ratio does not equal 1. But it allows us to convert from one species to another. I want to match the units and species here and on the bottom here. And I want to go to the other species that I'm looking for. In this case, it's the limiting reactant calculation, so that's the other reactant. We'll put moles of Ki on the top. Okay, and then the numbers we get for moles here come from these coefficients. Coefficients can give you numbers that tell you individual formula units or moles. And so we got 1 mole of the lead nitrate and 2 moles of potassium iodide. Cancel units and species. Sorry, Bailey. Okay, and now we need to convert this into grams. Okay, and so we need another molar mass, this time for potassium iodide. Let's see, since I've shown you how to do that, I'm just going to go ahead for time and put in the correct molar mass for potassium iodide. Let's see, it's going to be 166.90447 grams of potassium iodide, and we'll have 1 mole of potassium iodide on the bottom. Did anybody get anything other than this? Okay, I bet you multiplied potassium's mass by 2 and iodine's mass by 2, didn't you? Okay, this coefficient here does not apply to molar mass. Only the number of atoms in the formula apply to molar mass. Okay, yeah.
Is that 9094 or
90447. Okay. All right, cancel the units and species. Okay. And we're ready to find an answer. Okay, now, since everybody has a different starting amount, everybody's answer here is going to be different. Okay? And then what you have to do is apply the rule. The rule is, if this calculated amount, and this will be a mass of potassium iodide, if this calculated amount is larger than the amount you actually measured out to yourself, then this calculated amount is, or that species here, is the limiting reactant. On the other hand, if this calculated amount is less than the amount you actually measured out, then this species, potassium iodide, is the excess reactant, making the lead nitrate the limiting reactant. Does that make sense? Everybody clear with that? Okay. Huh? I don't know, because I don't know what your number would have been. I'd have to plug your numbers in and do the math. You had exactly 0.25?
No, I'm saying what it was.
Yeah, I had like 1.2.
Then you take this number, multiply by that number and that number, hit equals, and divide by that number.
Yes, I still got like 0.2. I basically got almost the starting amount. We started out with like 0.25 grams. I got like 0.25, or 0.2, yeah, 0.2519. So
Okay, so that rounds off to 0.25.
okay, so then like what if it is?
Huh?
So what if you get the same as when you started with? Then what is it?
Oh, I see what you're asking. Okay, so if what you calculated here is exactly the same amount, that's what you're asking, right?
When we round it off, it ends up being 0.25.
Okay, then you can choose either one of the reactants to be your limiting reactant, because they basically both run out at the same time. Yes.
You know how hydrogen, nitrogen, oxygen, chlorine, and chlorine are all like
Diatomic?
Diatomic. So when you did it for like mass of those, would it be like
2 of them.
2 times 2?
Yep. So you're looking ahead to the worksheet? Okay, let's stay focused on this right now, okay? Yep.
When I got the molar mass for potassium iodide, I got what's different than you got.
I did too, that's what I was going to say. I didn't get that for molar mass.
What molar mass you get?
166.0028.
That's what I got.
Yeah,
Yeah, that's what I got.
39.0983 plus 126.90447. Oh, you know what? You're right. 00277.
Yes, sir.
Okay, and you'll round that up to an 8, right?
Yes.
Yep. Okay, that's what it should be. You're right.
It was .20277. That'd be .002.
I still got the same answer though, either way.
Yeah, by the time you round it off, you get the same answer.
Yeah, so
That's fine. Okay, so if you started with the mass of potassium iodide, basically you're going to invert most of this stuff. Yep.
Like, I'm confused about limiting an excess reactant. Like, if you have, like, let's say your answer is like an excess reactant,
Yeah.
would that problem not have a limiting reactant?
Yes, it would. If you find the excess reactant to this calculation, then the other reactant is the limiting reactant.
Okay.
So if in this case, our potassium iodide amount is less than the amount we measured out,
Okay.
then that makes potassium iodide the excess reactant. Okay?
So that,
Then the lead nitrate would be the limiting reactant.
like, when you label a reactant, do you have to put like the number and the species?
No, if all you have to do is identify the limiting reactant. That's all you have to do.
Okay.
You don't have to tell numbers. Once you figure it out, the numbers are irrelevant.
All right.
Okay? Yes.
Is everybody going to have a different limiting and excess reactant?
Every lab group could have a different one. Yes.
Okay.
You won't have the same as the next person. I do it that way on purpose. Okay? All right. So all we have to do is invert all this stuff. We put 166.0028 grams of potassium iodide here. 1 mole of potassium iodide here. The molar ratio gets inverted so you can cancel out Ki. And let's see, and then this 1 mole of lead nitrate goes on the bottom here, PbNO32.
Is this still the math for the?
This is the limiting reactant calculation still. This is in case somebody started with potassium iodide instead of lead nitrate. Okay? So the math is just set up like this. All the units and species get canceled. Okay? And you end up with a mass of lead nitrate. You use the same process. One of these has to be excess, one of these has to be limiting.
unless you know the same as your starting amount, and then it's whatever.
Say again?
Unless you end up with like the same as your starting amount.
Then you can choose either one.
Okay.
Okay.
So if it's for my limiting, like for the end of this problem, I got 0.22 grams of potassium iodide, and like my starting grams of potassium iodide was 9.19.
So you calculated an amount that was, the amount you calculated of potassium iodide was greater, so potassium iodide is the limiting reactant.
Okay, so it wouldn't matter if it was the same as phosphorus at all? Or that wouldn't matter?
Phosphorus. You mean lead?
Not lead, yeah.
It's not supposed to, unless you happen to start with just the perfect amounts.
I started with lead,
Okay.
like on the problem, but I ended.
Yeah, you're just overthinking a little bit. Okay. Really, all you got to do is figure out what the limiting reactant is. That's it. Okay. Yeah.
Well, if you forgot the limiting reactant, what is the excess reactant?
One of these two is limiting, and one of these two is excess. That's it. That's it. Real simple.